Hi, how is it going? Today we are going to try to make a slightly longer video. The idea of this is that when one goes to make a purchase on internet and wants to get a product, it bothers me sometimes. Let's see an example. If I want to purchase this product, a piece of wood with a funny shape, if I want to purchase this over internet, the usual is that I will see an image of this and no much more. Perhaps an image like so, and another like so. And sometimes it really bothers me, because I want to see the object in all its glory, at least like this, 360 degrees. I know that some can do 360, like this and this, all over the place, but I'm okay just with this. And at some point, we had the opportunity to make some cards and stuff and to publish the photos or the product in internet. I said, I don't want a photo, I want to show everything. So I made a small device that can convert. Surely they exist. Surely there are mobile applications. I didn't search them because I like to do this, so why would I take something that is done and deny myself from the joy of making it? Well, to do this, what one would need, or what I would need, and yourselves if you want to do it too, is this. I don't know what is the name of this in Spanish. In English it is called Lazy Susan. I live in Australia. I've got it from Bunnings, which is a big hardware store. We will need some other things. We will need a wooden circle somewhat small, a wooden circle somewhat big. Later we will see this when I record the video of putting it all together. I expect it will show better. I need a belt, some small screws, some spring, the Lazy Susan as mentioned before, a step motor. I took this, I don't remember, probably from a print. I don't know, I don't remember from where. Oh, a driver for the motor. We will talk more about the driver later. And one, I am using a Raspberry Pi. Here I've got the driver with the connected cables. And there is the Raspberry Pi. Later I will show better what all those cables are. So if you want to do it, you can do it. We'll do a little bit of Python, a little bit of Bash, and a little bit of who knows what. This is only an introduction, and later I do more details. Well, in regards to the mechanical, this is done. Here we see that it moves. I think all is okay. Then we have 4 cables that come out of the motor. 2 are from a coil and the other 2 are from the other coil. If you have one of these motors and don't know which cables to use, get a multimeter and measure. Where there is continuity, that is a coil, and where there is no continuity, no coil. Simple as that. I've got the cables somewhat separated, a coil here and the other here. And these 2 go to the coil A. Not sure if you can see well there. In the A coil and the others go to the B coil, obviously. Voltage is connected to the driver, which are the first 2, and here I've got a power supply. I am using 20 volts. Then, here is something interesting. This driver, which is not the best. Later I could talk some more about the driver. This driver says that the pulse must be of plus 5 volts. But the Raspberry Pi can't supply 5 volts, it does 3.3. But it works anyway, it works. At the start I had troubles. I tried to make a voltage raiser, but in the end it wasn't needed. The Raspberry Pi, the pin number 5, is the blue cable, goes to the positive pulse. And this pin, which is ground or earth, goes to the negative pulse. And then, in the Pi, the pin number 6, and this switch is the plus 3.3 volts. I made it in such a way that when these 2 touch, the cycle starts. And what is a cycle? The cycle, the idea of a cycle is that the Raspberry Pi has a Canon camera connected by USB. Let's see if I can show it. This camera. Then, with the Raspberry Pi, I will be controlling the camera. That Canon camera over there will be pointing to the object over here in the table. Then the idea is that the Raspberry has some software that will act when these cables touch each other. Take a picture to the object placed here, move 10 degrees. Take another picture, move 10 degrees, take another picture, and so on until complete. The 360 degrees. The images, every time it takes a picture, I'll be saving it in the Raspberry Pi. And once the round is complete, we will compress all those images using FFmpeg in an animated GIF, and then we will see at the GIF, obviously. But well, this is the project. One more thing about the driver. The driver, this is the same driver. I don't know if it can be seen, but the driver has many settings. I am using the MicroStep 8, I think it is. MicroStep 8. Off on off. Yes. I am using Microstep 8. And with 1 ampere. So this limits the current that goes to the motor to 1 ampere. And it goes well. Later we'll see, this is the electric part. Later we'll see in the software section. Some things I had to touch. But well, I wanted to show the electric part. Now we are going to see the software section. Okay, let's see the software. The first thing I wanted to say is that I am using a package called PicBiot. Here it is, here you can see. But it needs to be running before starting the Python script. To find out if you have it working well, first it needs to be installed right. So we'll see here. And there it is. Here it is installed. This doesn't mean that it is running. Here you can see it is running. To make it run, you can use systemd. How is it? Systemd, you can search it up yourselves. Or do I do it? I'll do it. Let's see. There it is running. And to make it run, once it is installed, need to do, I think, do that and that's it. Okay, that is so that package is running. Another thing. The gPhoto needs to be installed too. Otherwise the Raspberry can't action the camera. At least the Canon camera I have. Having said that, I don't think there is a need for any other strange thing. Okay, import some things. From the pin 5 of the Raspberry Pi, the pulses will go out, the steps. And in the pin 6 is where I will put some voltage so the script starts. I'm not going to explain line by line, first because it would be too long, and second because I made this a long time ago and I don't really remember all settings. And surely there is parts of the code that I copied from somewhere. Okay, we'll put the step, the pin 5 as an output, and the start, the pin 6 as an input, and set the start to ground. Then a function called generate_RAM, which this I think I copied from somewhere. And here starts, I think I did this. Okay, to start with, the press variable is false, and this is a loop that runs all the time. So, if there is a voltage in start, and it was false, it turns to true. And then, this section of code is interesting. Here is where I call the function that I most likely copied, and I send those numbers. Those numbers are, the first one is the frequency, and the second number is the quantity of pulses. So, first I send 54 pulses at 500 Hz, then 200 pulses at 800 Hz, and then again 54 pulses at 500 Hz. Why is this? This is because at the start, when the wheel needs to start turning, there is inertia, and the wheel doesn't want to move, so I make it move slower. Once it speeds up, I make it go quicker, and then before stopping, I make it go slower again. It is just that. Regarding the pulses, I calculated by eyeing. How many were 10 degrees? I did a few tries and it gave me 312 in reality, not 310. 312 pulses at those speeds, at those frequencies are fine. I don't get why changing the frequency changes the amount of movement of rotation. There could be a few reasons for that. I don't want to go into those details, I really don't care. I care that it works. It is a prototype, so as long as kind of work, it is fine. It could be many things. One possible reason is that the voltage pulse is 3.3 and the driver needs 5, so maybe that is related. So, perhaps not all the pulses are, whatever, doesn't matter. Then, it sleeps for a second so the wheel stabilizes. Perhaps that is not needed, but hey, there it is. Then I call a bash script. That is where the picture is taken. G-photo was start. Here it is. Here, what this does is, first kills those two processes, if they exist, and then it takes a picture and saves it. In the Raspberry Pi, it is not being saved in the camera. That is all it does. It takes pictures and saves them, takes pictures and saves them. This happens 36 times, until it completes 360 degrees, the whole round. Once we have all the images are saved in the desktop. What this part of the code does is, it takes all the numbers of the images. The images have a format. They start with AMG_, then a 4-digit number and .jpg. So, this places all the images names in an array. They are ordered. And once ordered, take the lowest one. I take the IMG_ and look at the number. We are talking about the lower number. Between the 4 and the 8, the 4th and the 8th character. I print the number because it's nice to see.
Y este número,
and we will pass that number here.
acá, este número,
This number will be here.
a otro script,
It
bash
goes to
script,
another
que es
script,
donde
bash script, where the
va a crear
GIF will be
el
created.
GIF. Y el GIF,
And the
bash,
GIF, the bash,
es
is
este.
this.
So,
It uses
el GIF
FFmpeg. We need to
y
have it
ahorita no lo he
installed.
instalado,
I
creo
think
que
it
viene
comes by
instalado por
default.
defecto. Le metí
I
un
put a frame rate of
5
5
y empieza
and
en
starts
la
in the
imagen
image number,
número, el
the
número
lowest
menor
number
de
of all
todas
the
las
images. And this
Este
number that
número
is
que
here
está acá se va
is
a
going to
poner
end up
acá.
here.
Entonces el
Then the
FFmpeg
FFmpeg
va a
will take
agarrar
all the
todas las
images,
fotos
starting from
empezando
that
con este
number.
número, las va a poner en un
It will
frame rate
arrange them in
5,
a frame rate of 5
5
frames per
frames per second,
second,
y lo va a guardar en
and it will save the example.gif in the
en el
desktop.
desktop.
And
Una
once
vez
it
que
is
ya está,
done, it is done. The script
terminó
finishes.
el,
It
terminó
doesn't
el
do
proceso, no
anything
hay más.
else.
Así que
So, eventually, here will be all the images, and we'll have the example.gif, which we'll open with the browser. But, for that is the next section, the last one. Okay, I place this toy in the middle of the circle. Pretty good, there's the center dot. I put some sticky tape here and on the other side too, so it doesn't move for vibrations or whatever. We've got all ready, the power supply at 19 volts. I don't know why not 20, it is at its max. We've got the little motor all good, all connected. The Raspberry Pi there, the machine ready, in fact. There, if you can see there, the script is started. But I didn't touch the cables yet. It is there. Once I put 3.3 volts there, it will start to move. I've got the camera. Ready, the camera ready looking at the monster. Let's turn on the camera. There it is. There the computer recognized it. Let's cancel. Now we touch the cables and see what happens, hey. I wonder why. Oh, I know why. No, I don't know why. That the images are not showing in the desktop. Okay, let's wait. Seems like the Raspberry Pi has some issues to process. All the information I don't know in previous opportunities. This was a bit quicker, much quicker rather, there wasn't so much delay. Between one and the next the functioning was smoother. I think it finished. It is in the starting position. Let's see if there is anything in there that says something. In the end, yes, it worked all right, very slow, some things. It looks the poor Raspberry couldn't manage it all. Right now I am recording its image, so it will be worse. But well, all the images are in the desktop and there's the example.gif. Let's see if we can minimize this. Here we have the little device in a normal website. Okay, but if that image was as the other one, as the one I just made, it would be something like so. With some photography work, obviously this is a prototype, right? But one could put a nice background and base, and this would be much better. And this is the objective of this video, that the products are shown in this manner. Not like this.
Ese es mi sueño. Hasta luego. Que lo pasen bien.